In this video, we're going to discuss some of the ideas from chapter 14 in the book. We're going to describe the relationship between architecture and its environment. We're going to outline the architectural technologies that predate the modern era. We're going to describe the technological advances that have contributed to modern and contemporary architecture. And we're going to describe how the idea of community serves as a driving force in architecture. So the look of buildings depends on really two factors, the environment and technology. So the materials and methods available to the culture. American architect I.M. Pei won the commission for the plan to expand the Louvre Museum. This resulted in the underground center topped with the now iconic glass pyramid. A building's form may echo or contrast the world around it, or respond to the climate. The significance of the pyramids of Egypt may rely upon the image of the god Ra, symbolized by the rays of sun descending to the earth. Architects conscientious of climate change have created more environmentally friendly and sustainable practice known as green architecture. Green architecture is characterized by smaller buildings, integration and compatibility with the surrounding environment, energy efficiency and solar orientation, and the use of recycled, reusable, and sustainable materials. Walls may employ one of two basic structural systems. The shell system involves one basic material providing both structural support and outside covering, often would be solid all the way through. The skeletal and skin system consists of a basic interior frame that supports a fragile outer covering. Walls of the lower floors must also support the weight of the upper floors. Tensile strength is the ability of a building material to span horizontal distances without support or buckling in the middle. Load-bearing walls must bear the weight of the roof. Post and lintel construction consists of a horizontal beam supported at each end by a vertical post or wall. The Lion's Gate in Mycenae in Greece features stones so large that the ancient Greeks believed it only could have been built by the mythological Cyclops. This type of construction is fundamental to Greek architecture. Each column in the first temple of Hera is made from several pieces of stones called drums. Grooves in the columns are called fluting and run vertically. Each column tapers slightly at the top and bottom, known as entasis. Greek temples are situated on an elevated acropolis, the center of civic life. Colonnades, or rows of columns, were constructed according to rules of geometry, equity, and proportion. Three types of Greek columns are Doric, Ionic, and Corinthian. The vertical elevation of the Greek temple is comprised of the platform, the column, and the entablature. The relationships among these units is called the order. The elevation of each order begins with the floor or the stylobrate. The column of the Doric order consists of the shaft and the capital. Romans perfected the use of the round arch, which allowed them to make structures with a larger span. Wedge-shaped bassours are cut to fit the semicircular form, and a keystone is added at the top center to ensure equal pressure. The barrel or tunnel vault is an extension in depth of a single arch. The Colosseum is an amphitheater with two semicircular theaters brought face to face. It is supported with barrel vaults and groin vaults. Romans also perfected the dome, as demonstrated in the Parthenon. The poured concrete is over 20 feet thick where the dome meets the walls. The oculus at the top of the dome is the building's source of illumination. Roman interior architecture came to inspire later Christian churches. The barrel vault at St. Cyrnon typifies Romanesque architecture. Every measurement is based on the central square at the crossing, where two transepts cross the length of the central nave aisle. The apse at the end of the church is topped by a Roman half dome. Immense interior space was a feature of Gothic cathedral architecture. The Amiens Cathedral interior achieved a height of 142 feet. This interior space was achieved with a pointed arch, which was used to distribute the weight of the roof more directly down the wall. Since all the arches spread the weight outward and create a risk of collapse, flying buttresses were created to support high arches from the outside. The arches and buttresses allowed the stone architecture to achieve lightness and are an aesthetic response to a practical problem. Prior to the 19th century, architecture was limited to innovation in stone. In the 19th century, iron transformed the built environment. By adding carbon to wrought iron, engineers created strong and rigid cast iron. The Eiffel Tower was the tallest structure in the world when it was built. The open skeleton allowed for wind to pass through, though Parisians hated it at first. Lumber was better suited for domestic architecture, and in 1833, wood frame construction was introduced. Sometimes called balloon frame construction, the method is inexpensive and relatively easy. The walls of Old St. Peter's Basilica utilized the basic principles and elementary triangular truss. Frank Lloyd Wright worked as a draftsman in the Sullivan Chicago firm until 1893. His Robbie House was built in 1909 and was intended to be organic despite its contemporary feel. The Prairie House featured a cantilever that provided protection while one was outside. Steel provided the means for constructing skyscrapers. A steel cage connected by floors made of reinforced concrete. Concrete in which steel reinforced rebars are placed overcomes the necessity for thick walls at the structure's base. Thinking through architecture, Frank Lloyd Wright's Falling Water. The first drawings for this famous house weren't completed until 2 hours before Edward Coffin made a surprise call requesting a draft. The house was wedded to its site, a hillside atop the Bear Run stream. Kaufman, as well as the contractor and engineer, did not trust Wright's plans for reinforcing the concrete for the cantilevers. They put twice as much steel as Wright called for, and it caused the main cantilever to droop.